Okay, welcome to lecture number 3, and I am going to continue from the last lecture. In the last lecture, we have taken one circuit with RL load, and for that load, we have plot the graph for the power, and in that power, we have seen that we have both real and reactive power. Now, we are going to separate that real and reactive power in the last class circuit. So, I will take the circuit again. So, this is the circuit we have taken. So this is R, this is L. So this is been connected to a source. So this will be plus minus V, and this is resistive load and this is the inductive load, and current flowing here it will be I. So if I take this one, so I am taking V is equal to Vm sine omega t, and I have taken I is equal to Im sine of omega t minus theta. So this is the two expressions we have taken, and now I am going to derive the expression for power. So power, we know that, which is nothing but it is V into I, instantaneous power. So I'm just going to multiply these two expressions. So if I multiply these two, I can write it as Vm Im, this is sine omega t, and this will be sine, I will write it in clear, sine of omega t minus theta. So now we know that sine of a minus b will give you sine a cos b minus cos a sin b. So this, I am keeping these three things as it is, sine omega t, and instead of this one I am going to write sine a cos b minus cos a sine b. So this is the expression. I have just expanded the sine of omega t minus theta. So now I am just going to multiply this term. I am just going to bring this three terms inside the bracket. So I will get Vm Im, and I am having this cos theta. I am just keeping this cos theta as it is. And if I multiply these two, I will get sine square omega t. Sine square omega t. That's all. So minus, and I am just bringing this one to here. So I will get Vm Im sine theta. So Vm Im, this sine theta I am just keeping as it is, and these two will come. So this is nothing but sine omega t cos omega t. That's all. So this is my two expressions now. So in this expression, now what I am going to write you, so you see here, sine square theta can be written as 1 minus cos 2 theta divided by 2. That is one formula we know, and also sine a cos a can be written as sine 2a divided by 2. So with these two, I can I'm just going to substitute these two in this particular expression. So you see here it is sine square omega t, so that I can write it as 1 minus cos 2 omega t divided by 2. So I am just substituting in this equation. So this will give you Vm Im sin theta will be here yes, Vm Im, this is actually cos theta. Instead of this sine square omega t, I am just writing this one. So how I will write this one? So 1 minus cos 2 omega t, and this divided by 2 I am just writing here. That's all. Minus, I'm just going to write this expression Vm Im sin theta, Vm Im, this is sin theta, and in bracket I have to write, instead of sin a cos a, you see this one, both are same. So sin omega t cos omega t, I can write it as sin 2 omega t, and this divided by 2 I am just writing here. So this is the two expressions. So now I am going to take, this is my first expression and this is my second expression. So I am just writing the first expression. Now what I am going to do, I am just going to substitute omega t values. So I am going to draw the graph now again. So in that graph we have splitted in the last class, like 0 degree, 45 degree, 90 degree, like that I am going to split. So before that I am just going to substitute my omega t value, which is equal to 0 in equation number 1. That means this first expression, not equation number, first expression. So if I substitute theta is equal to omega t is equal to 0. So this is Vm Im by 2 cos theta 1 minus, you see here this is cos 2 omega t, 2 into 0 will give you 0. So cos 0 value, so this is nothing but cos 0. So we know that cos 0 value will be 1. So this value will be 1. So 1 minus 1 will give you 0. So this whole term becomes 0. Which means I am writing here at omega t is equal to 0, this term becomes 0. So next I am just going to substitute omega t is equal to 0 in the second term, this term. That is nothing but minus Vm Im by 2 sin theta in bracket sin 2 omega t. Sin 2 omega t. So what is that? Sin 2 into 0 will give you what? Sin 0. And what is sin 0? Sin 0 will be 0. So this term becomes 0. So the whole term becomes 0. So whole term becomes 0. So I am just writing here that omega t, if omega t is equal to 0, this second expression also becomes 0. So now I have to substitute omega t is equal to 45 in the both expressions, and again I have to proceed the whole thing. So I am just going to show you that whatever the expressions we are getting for all omega t's. Okay, now you see I have just derived all the expressions now. This is the first term. We have seen this is our first term and this is our second term, and instead of omega t I am just substituted and I have got all the expressions. Now I am going to substitute in this graph now. So in this graph you see I am just going to take, okay, I am just going to take this as my omega t and this is my, what is this, first expression, maybe first expression, and I will mark down the points now. So I have taken x-axis as 45-degree split ups in the both expression. I am going to draw the first in this graph and the second expression in this graph now. So now you see you have Vm Im by 2 cos theta and Vm Im cos theta is there. So I am just going to take, this is my Vm Im by 2, this is cos theta, and this I am taking it as Vm Im cos theta. This is my first thing. In the second you see Vm Im by 2 sin theta minus value and another one is plus value. So I am just going to take, this is my Vm Im by 2 sin theta, and this I am going to take it as minus Vm Im by 2 sin theta. So now I am just going to substitute all the values. So for 0 degree, for the first expression it is 0. So for the 0 degree, for the first expression I am getting 0. For 45 it is half of this value, that is Vm Im by 2 cos theta. So Vm Im by 2 cos theta, and for the 90 degree it is Vm Im cos theta. So this is Vm Im cos theta, and for 135 degree again it has become half. So it will come here. So at 135 degree, and at 180 degree it is again, it is becoming 0. So this becomes 0. At 225 degree again it becomes Vm Im cos theta by 2. So this I am getting for 225 degree, and for 270 degree again it has become maximum value Vm Im cos theta. So this at 270 degree I am getting this, and for 315 degree I am getting Vm Im by 2 cos theta again. So I am just marking here. So this for 360 degree it is actually becomes 0. So I am just going to connect all these values, all these points anyway. So this will come here, and you take this and it will go here. These two are connected, these two and these two. Okay, fine. Now this is for first expression. This is for first expression, and I am going for the second expression now. So at 0 degree it becomes 0. So at 0 it becomes 0, and you see for 45 degree it is minus Vm Im by 2 sin theta. So at 45 degree it is minus Vm Im by 2 cos theta. For 90 degree again it becomes 0. So for 90 degree again it becomes 0. For 135 it becomes plus value. So you see it 135 degree. At 180 it becomes again 0. At 225 you see it is inverted, which means minus term. At 225 degree again it is a minus term. Anyway, I will bring this here. Okay. So at 270 degree it is again it is becoming 0. So this will 0. 315 degree again it has become positive half. So positive, and 360 degree it becomes 0. So this is how. So now I am going to connect all these points again. So this this will be connected, and again, and these two will be connected, and these two will be connected, these two, and again these two, and these two will be connected, and these two. Now this is my second expression. So now you see what is my first expression peak value. This is actually this one, 1 minus cos 2 theta. At 1 minus cos 2 theta, cos 2 omega t, this graph is existing. So what is my expression here? It will be Vm Im by 2 cos theta. And what is this expression? This is actually going in the sin omega t term and minus sin omega t term. So what is the expression I am getting here? Vm Im by 2 sin theta. So this is the first expression and this is the second expression. And you see this expression now, you can see that there is no negative terms. All values becomes positive here. Maybe this graph is coming to 0, but it never gets to negative. So this is actually power curve. This is for first expression power curve. This is the second expression in the power expression. So now you see this expression never becomes 0. And what it actually means, if my power is not getting to 0, which means all the powers are transferred from source to load. So all these powers will be real power. All these powers will be real power because it is flowing from source to load. And now you see this value, this is getting minus, this is positive, this is minus, and this is again positive. And now you see if it is negative, then what happens here? If power is negative, then the power is transferred from load to source. Again, here if it is positive, it is actually flowing from source to load. So again it is coming from load to source, source to load. This is called oscillating power. Oscillating power. I am calling it as oscillating power, and this power, which is nothing but, I am calling it as reactive power. This is nothing but reactive power. Right? So now you see I can easily write P real, which is nothing but Vm, maybe this 2 I am just writing it as divided by, this is root 2 Im by root 2 cos theta. So now you see this expression can be, if you multiply these two, you will get 2, right? Vm by root 2 will give you what? RMS value. This is nothing but Vrms Irms cos theta. That is the real power. And if I want to write for reactive power, and what I will get? Vm by root 2, this expression. I'm just writing, I'm just splitting this root 2 into root 2, then it has become sin theta. So that I will write Vm by root 2, again it becomes Vrms Irms sin theta. So now you see this is the expression for real power and this is the expression for reactive power. In real power, you see your power will not get to negative, which means all the powers has been transferred from source to load, only source to load, which means my power is always positive. And you see not only the negative power, we are calling it as reactive power, but you have to say that whatever the power is oscillating between source and load, we are calling it as reactive power. And so many students makes mistake here. What they think of, whatever the power is coming from load to source is only reactive power. No, it is not like that. Whatever the power oscillating between source and load, we are calling it as reactive power. You have to remember this very clearly. So that is what I have given you an example. In that example also I have told you that whatever the power is coming from the load to source is called reactive power, but it is not actual thing. You have to understand oscillating power. This power will oscillate between load and source, but never utilized by load nor utilized by the source. That power we are calling it as reactive power. So this is how we can classify the real and reactive power. This is the mathematical proof. Now in so many books you have seen that Vi cos theta is, which is nothing but real power, and Vi sin theta, which is nothing but we are calling it as reactive power. Okay, fine. If you have any doubts, you please comment in the comment box so that I can easily approach you. Thank you. Thank you.